to move in a straight line. To move in a straight line. Okay. So the object cannot change its direction on its own. Without any force, it cannot change even its direction. So this situation is called as inertia of direction. So inertia of direction, it is felt with various examples, various situations where we observe the inertia of direction. For example, when we are sitting in a bus or a car and it takes a circular turn. So when a bus or a car takes a circular turn, so during that time we experience an outward motion, we experience an outward force which is experienced by us. So all of us experience an outward force when an object or when a bus moves in a circular path. So suppose we have a circular path and we sit in a bus or car which moves in this circular path. So at every point, suppose if it takes a circular turn over here, so at this point, we will experience that our tendency, if we are moving like this, so our tendency will be to move in a straight line. At every point, we will have the tendency to move in a straight line like this. Okay. So our tendency of movement in a straight line is changed. We are up, the bus takes a turn, that means the bus tries to move like this, whereas our tendency is to move in a straight line. So it is because of this we experience an outward force. Okay. So inertia of direction is the tendency of all the bodies to move in a straight line. So I think all of you must have seen, suppose you have a ball over here and I want to send it to this point. Okay. So should I send it in the straight direction or should I throw it somewhere else? I should throw it in the straight direction from this point to this point to reach it. Okay. Because we know that the object will travel in a straight line. So all objects, they have a tendency to retain their directions or they have a tendency to move in the straight path. Okay. So this tendency we observed here in different situations, like we observed the sparks coming up, the mud coming up from tires. So all those situations, they show us the inertia of direction. Okay. So I think now everyone has understood about inertia. Yes. Inertia being the tendency of an object to resist any change in its direction. So all objects, they want to move in a straight line. When they are moving, they want to continue in their straight line. They do not want to change their path. So this situation is called as inertia of direction. Got it? Now we start, let us state Newton's first law of motion. So Newton's first law of motion, also called as the law of inertia. All of you can keep your camera on. If you are facing any issue regarding the camera, do inform. Else, okay. So Newton's first law of motion. This is the basic law which comes from the inertia. It is also called as the law of inertia. Okay. So the Newton's first law of motion, it states that it's Jitendra, are you there?
Yes, sir.
So according to the Newton's first law of motion, every body will remain its state of rest
Unless an external force is acted upon it, right, sir?
will remain in a state of rest or of uniform motion in a straight line.
Sir, after this, can you once again define inertia of direction?
Okay, I will do. So every body will remain in a state of rest or of uniform motion in a straight line unless acted upon by an external unbalanced force. So unless it is acted upon by an external unbalanced force, the object will remain either in the state of rest or of uniform motion in a straight line. There will not be any change unless you apply some external unbalanced force. So the internal forces will not bring about any acceleration. They will not bring about any changes in the state of motion. See, what do we mean by internal forces? Okay. So let's discuss here something about the internal forces and what does this first law of motion tell us. Okay. Suppose you are sitting in a car and trying to push, you are sitting in a car in the back seat and you are trying to push the forward seat and you expect the car to move. So is it possible for the car to move?
No, sir, because we applying internal force, we can
Yeah.
only push the car if external force is applied on it.
Yeah. So that whatever force we are applying, that is an internal force. It cannot bring about any change in the state of motion. To bring about a change in the state of motion,
Yes,
you
sir.
must apply an external unbalanced force. The forces must
Yes,
be
sir.
unbalanced, then only there will be a change in the state of motion. Okay. So all the examples which we observed, for example, if you keep a ball at a place, it will remain at that place if there is no external force. And if you want to move that ball from that place to some other place, you must apply some external force to make it move. Okay. So this is the Newton's first law of motion. Every body will remain in its state of rest or of uniform motion in a straight line unless acted upon by an external unbalanced force. So you see certain examples which illustrate us the Newton's first law of motion. Okay. Before that, I think someone asked here, so, the definition of the inertia of motion. So it is the tendency of an object to move in a straight line, or it is the tendency of an object to resist any change in its direction. So we can say tendency to move in a straight line or to resist a change in direction. So this is your inertia of direction. Okay, anyone having any doubt regarding this?
No, sir.
So let's move to the Newton's first law of motion. We have stated Newton's first law of motion. It expects or it gives us an idea that if you want to bring about any change in motion, if you want to increase the speed, if you want to decrease the speed, if you want to change the direction of a moving object, so there must be an external force which will be acting on it to move it in any direction. Okay. Can anyone give any example of the Newton's first law of motion?
Sir, a bullock cart we can't, in a bullock cart, we can't push the bulls by sitting inside the cart.
Okay. So we can't push a
Yes, sir.
bullock cart or any vehicle by sitting inside it. That is one example. Any other example of the Newton's first law of motion?
Sir, pushing the cupboard door from inside a cupboard is not possible.
Okay.
I mean,
So that
pushing
will
the whole cupboard from sitting inside is not possible.
okay. So these are various examples where we apply the Newton's first law of motion. We see that if an object is in rest, it will remain in the state of rest. So which we have also studied in the law of inertia. We have studied the inertia of rest, that if something is in the state of rest, it will remain in the state of rest. For example, a
There isn't
coin
the
being
first
flicked.
law called the law of inertia also.
Yeah, that is why the first law is also called as the law of inertia. because it basically deals with inertia. It explains only inertia. Okay, it does not give you what quantity of force is there. Now, if you are asked what is a force, so the definition of force, it comes under the first law of motion. Okay, so now let's here define also what is force. Okay, so up to now we have defined force as a push or a pull.
Yes, sir.
So for a better definition, we get here inertia force as an interaction between two bodies, an interaction between two bodies that tries to bring about a change in the state of motion, in the state of motion or of shape. Okay, so a force will be an interaction. It will be defined as an interaction between two bodies. So whenever two bodies interact with each other, so we say that they are applying forces on each other. So force is defined as an interaction between two bodies that tries to bring about a change in the state of motion or of shape. Also, as a measure of the motion, as a measure of the inertia, we have seen that the inertia depends on the mass of object. Okay, so shall we continue with the next second law of motion? Can we start with the second law of motion now?
Yes, sir.
Jitendra, Sampath, are you there?
Yes, sir.
Yes, sir.
So let's continue. So before the second law of motion, the first law of motion, it defines the force. First law of motion, it tells us that under what conditions you can't bring about any change in the state of rest or of uniform motion. So before coming to the second law of motion, we have another very important term which deals with it, that is momentum. So you might have heard this word momentum before also. So momentum, it is the amount of motion content it is the amount of motion content of an object and
Sir,
yes.
sir, can the definition be the product of the mass and velocity or speed of the object?
Okay, I'm giving it here. It is the amount of motion content of an object and is measured as the product of mass and velocity. That's what my next line.
Yes,
So
sir.
momentum, it is measured as the product of mass and velocity.
Sir, what is it represented by?
Momentum, it is represented by the symbol P, small letter P.
Okay, sir.
By P, and it is a vector quantity. So momentum is a vector quantity. It has a direction. Can you tell in which direction does momentum act?
Sir,
Yes,
in the direction of the velocity.
in the direction of velocity. Yes, the direction of momentum is the direction of velocity. So it acts in the direction of velocity. So we write here momentum P. Momentum P will be given by the product of mass and velocity. M multiply V, and the direction of momentum will be the direction of velocity. Now, the quantity momentum, it is a vector quantity and its SI unit. So SI unit of momentum. Can anyone tell the SI unit of momentum?
Sir,
Sir, kg per meter per
kg per
second.
meter.
Okay. Mass will be
kg
measured in
multiplied by
kilogram.
meter per second.
Okay, so it is kg meter per second. Mass is measured in kilogram, velocity in meter per second. So the momentum is measured as kilogram meter per second. Akshara? Yeah, Akshara? Akshara, are you able to unmute? If you are not able to unmute, just a message over here in the chat. If you are there. So momentum is measured in the SI unit kilogram meter per second. So let us find out this answer. Let's solve this question. Find the momentum of a ball of mass 250 gram moving with the speed of 25 meter per second. Okay. So find out the answer. Yes, find out the answer now.
Sir, the answer is 6,250 gram meter per second.
Okay. So 620 you are getting.
sir,
Sir,
6.2.
6,250.
Okay. So why you have not converted your mass into kilogram?
Sir, 6.25 will be the momentum, 6.25 kg meter per second.
Okay. So
Sir,
it is,
power cut
yes.
that left the meeting. I had a power cut.
Uh, what happened?
Sir, I had a power cut, so I left the meeting.
Okay, okay. No issues. No issues. Continue. So you have here in the next question a cycle of mass 45 kilogram moves with speed of 15 meter per second, and a boy of mass 50 kilogram runs with a speed of 10 meter per second.
Sir, can you once explain how to solve the questions?
I'm just giving you question. Try to do this, then I'll be solving it out.
Yes, sir.
Okay. Just try to do this. I'll solve them out. Okay. So which one has greater momentum? So these are the two questions. You have to find in the first one, you have to find the momentum of a ball of mass 250 gram moving with a speed of 25 meter per second. And in the second question, you have a cycle of mass 45 kilogram moves with a speed of 15 meter per second. And a boy of mass 50 kilogram runs with a speed of 10 meter per second. So you have to tell which one has a greater moment.
Sir, the cycle has a greater momentum.
Okay, let's check it out. So for the first question, for your answer number one, this is your question one. So for answer number one, we use the formula of momentum equals to mv and the mass is 250 gram, which is 0.250 kilogram, multiply with 25. So if you multiply, you will get here 6.25 kg meter per second. Got it? In the second question, you have to find the momentum of both the quantities. So momentum of first quantity, that is cycle, will be 45 multiply 15.
675, sir.
How much? 675.
Yes, sir.
Okay, kilogram meter per second. And then you have to find the momentum of the second quantity, which is 50 multiply 10.
So the first quantity has greater momentum.
Yeah, the first quantity has greater momentum. So that means cycle has a greater momentum, whereas the man has a lesser momentum. So see, now see another question here. A ball of mass 100 gram, sorry, 150 gram strikes a wall and returns with same speed. With same speed of 36 kilometer per hour. Find the change of momentum. So can you find the change of momentum? Okay. So the formula remains the same to find out the momentum. The only thing you have to find a change of momentum. Okay. So let's do this question. Mohammad Rayan,
Yes, sir.
okay, can you find out the change of momentum? Yeah, Mohammad Rayan,
Yes, I'm doing.
Sampath, Jitendra, Akshara,
Yes, sir.
are you solving out this question?
Yes, sir.
Okay. Okay. So
Sir, the momentum is 1.5 kg meter per second.
I want the change of momentum.
Okay, sir.
Sir, would the change of momentum be 0?
How can it be zero? See, remember, momentum is a vector quantity.
Sir, can you explain?
Mhm. Okay, see, just we have discussed that momentum is a vector quantity, right? Consider our ball, this be our wall, and let us say the ball being let's say we have this ball. So now our ball moves with a speed of 36 kilometer per hour and it strikes this wall. So it strikes the wall with the same speed 36 kilometer per hour. So we find out here its initial momentum which is directed towards the positive direction. If we consider here the right direction to be the positive direction, so the direction of motion here is positive and hence initial momentum, I can write my initial momentum to be equal to 150 gram divided by 1000. So that is 0.15 kilogram multiplied with 10. So its initial momentum will be 1.5 kilogram meter per second. This is the initial momentum. Okay. Now, when the ball returns back from this, so when the ball returns back after striking the wall, suppose the ball returns back like this. So when it returns back along the same path, now it has its velocity again 10 meter per second. Your 36 kilometer per hour converted to meter per second is 10 meter per second. Everyone knows to convert it. So 36 multiplied 5 by 18, that is equal to 10 meter per second. Okay. So I think no doubt here in 1.5 kilogram meter per second.
No, sir.
Now when this ball returns back, after striking, when the ball returns back, so it comes with the same speed, but now see the direction of velocity has changed. Now it is moving towards the left direction. Okay. So I shall be taking its momentum to be negative now. Now its final momentum will be taken as negative since velocity is negative. Now the velocity is negative 10. It's not the same. Okay. So its final momentum will be 0.150 multiplied with negative 10. So its momentum would become negative 1.5
Sir, would
kilogram
the
meter per
change in
second.
sir, would the change in momentum be 3 meter per second? I mean,
Yeah, the
3.
change in momentum would be 3 kilogram meter per second. Negative 3 kilogram meter per second. Got it?
Yes, sir.
So anyone whose doubt is not clear here? Pranava? Pranav?
Can you explain once more?
Yeah, Rohit?
Sir, could you explain how you got -3 once more?
Okay, so first let me complete it finally. So your final, I have to find the change of momentum. So which is written as delta P. Delta P means change of momentum. So change of momentum will be found out as final momentum minus initial momentum. So our final momentum is negative 1.5 and minus initial momentum is again 1.5. So both are negative. You add them, you get negative 3 kilogram meter per second. Got
Yes,
it?
sir.
Okay. So you have the change of momentum as like this minus 3 kilogram meter per second. And now you want to understand how it happened. So see, we observe the ball to be moving in two directions. Initially, the ball was moving towards the right, and after it strikes, so the ball comes back. Now the direction of motion is opposite. It's not the same. So we observe here motion along two directions. If we consider this to be our axis, and let's say here we make the origin. So initially, the ball was moving towards right. So its direction of motion will be taken positive. And if it moves towards left, so its direction of motion will be taken as negative. Okay. So that is why we get our answer as negative 3 kilogram meter per second. So Rohit, your doubt is clear?
Yes, sir.
Now shall I give you one more question? Yes? Will you try out one more question? Let's see. Okay, Pranava, when you join late, so you have to you have to look for the previous video. Okay, in short, what is the video after the class? Because here what I can do is I can just show you what we have discussed. Okay, so we have discussed here inertia of direction. Then we have discussed Newton's first law of motion. We have discussed force, momentum, and this is continuing. We are continuing with momentum. Okay, Pranav. Now let's
Yes,
see
sir.
one more question. Let's see another question here. So you have a ball of mass 350 grams is dropped from a certain height. It hits the ground the speed of it hits the ground with a speed of 70 kilometer per hour. If it rebounds with 50 kilometer per hour, you have to find its change of momentum. Okay. So find here the change of momentum. A similar question, a little bit with a little bit of change. The question we did just now, there's a similar question with a little bit of change. Okay, so anyone who is able to do, for a hint, use the decimal number. Okay, do not use fractions, just change to decimals. Change 70 kilometer per hour to meter per second, 50 kilometer per hour also to meter per second, and then find out the change of momentum. Okay, Jitendra, did you get the answer?
I'm still doing, sir.
Akshara, are you able to do the question?
Yes, sir.
Okay, so do this question as part of your homework. Right? To do it as a homework, just take again the similar concept, positive direction, negative direction. Got it? Okay, so bye all of you. Try to do this question.
Yes, sir. Thank you, sir. Bye, sir.
Thanks, sir.
Bye.